Okay, so I've linked the Jupyter Notebook, which I'll be using in the following slides, and so I encourage you to also look at this and play around with it by changing some parameters and seeing how the results change in the process. We can very easily incorporate API calls of bioinformatics tools into our code using the documentation, like I've described earlier. And so, for example, to use the Enricher API to get all the gene sets related to a biomedical term, we would use the JSON library. And so looking at the request URL, which we find in the documentation, we can simply specify the enricher URL. And with this endpoint, which is the term app endpoint, which is what we would want to use. And then we would then specify what term we would want. And so here we see that the full URL that we see in the documentation has it formatted like meta is equal to the term that we put in as our input. And so in our code, we can replace this term with the %s operator, which would enable us to do string substitution to create the full request URL. So here we have the request.get, and this is our URL, which would look like this, but with this replaced with the term diabetes because of this, on the way this is formatted. And here we on the next line, we're also then checking if the response is okay. And so if the response is not successful, i.e. if it wasn't like a 200 or anything or a redirection, it would raise an exception, which would basically tell us that something is that we're not able to get a valid response. However, if the response is okay and we don't fall into this condition, we're then able to use the JSON.loads function in order to load in the text and then transform that into a Python object. If we would then like to specifically look at the terms from the disgennet library, based on the structure of the output, which we were able to see earlier, we would just simply index into terms and then index into the disgennet library. Similarly, we can do the same to perform kinase enrichment analysis to find the enriched kinases of an input gene set. And so using the Kia3 API documentation, we can structure our code pretty similarly to the code example that we see in the API documentation. And so copying this bit of the code that we see in the documentation, and we paste it in our own code. So this is the structures for making requests in Python are pretty similar once you understand it. And so here it's essentially we have a URL, but this is a post request. So we have a payload. And like I described earlier, we're then using JSON.dumps in order to convert this Python object into a string, which we can send with our post request. After which, if the response is okay, we then load this response to convert it back into a Python object. And so we see here that calling this function on our input gene list, we're able to get this result from Kia3. And from here, we can then use this to get our enriched kinases. If you and the way this is structured, it would be very easy to then modify to then pass in a new gene list, and so we can make this basically this function is then reusable for different different gene sets. Making API requests for the GraphQL APIs are a little different, and so for example, let's try to get information. So essentially the title or gene sets about a publication with a given PMC ID using the PMC info by PMC ID endpoint. After finalizing what you would like your query to look like in the IDE by selecting these options, you would then copy this auto-generated query here, and then you would paste it into a JSON string here. this is the JSON string that you would then use to make a post request to the Roma-Gene URL. But in this JSON parameter, when you're sending with the post request, you would essentially be making a dictionary and mapping the key value query and mapping the key query to this JSON string that you have that contains the query that you copied from the Roma-Gene graph from the Roma-Gene post graph IQL IDE. You see here that we use the .json here. We use the .json function to then extract the JSON response from this post request. And we see an example of what that would look like here. However, we can see that the genes that we get from these, like the genes that define this gene set from our response are not really formatted properly. So the way it works is that we selected that we wanted the gene IDs returned. And so in order to transform this into an actual gene set, we would then use the gene endpoint, which would take in a gene ID and then convert that into and then use that to extract information from the Roma-Gene database about a specific gene. Using this, we would create a function called getGeneSymbol. And here we can then use this exact query structure to pass in a gene and then get its gene information. Here we then use a post request similarly with the same key value pair of query with the JSON string of what our auto-generated query would look like. And here from this function, we're able to get for a specific gene ID, we get its ID, its NCBI gene ID, its summary, symbol, and description. What we really care about is on the symbol. And so looping through each of the gene IDs that we get back returned from this function, we're then able to make a for loop to extract the symbol. Based on the structure here, we see that we have data and then gene and then symbol. Then we can get our gene symbol from here and append it to a final list, which we can call our gene set list. To perform mutations, we will need to structure the function slightly differently. So first we can create we create an operation name and then what variables that this operation should take in. The operation name can be anything, but I've chosen add user gene set similar to the operation that I would like to perform. The variables will then be the description of the gene set and the gene set genes. Afterwards, we then specify the data type for the input parameters that the function will be taking in. So the genes are a list of string, while the description is a string. We can then use the query schema that we constructed in the Roma-Gene GraphQL IDE, which includes the desired output fields, and paste that into our newly defined function. But now in this case, we would replace the parameters with we would replace the input parameters with those that we have defined in our new mutation function. To view the enrichment results of our added gene set in the Roma-Gene website, we will need to pass the dataset ID that we get a return from this post request as a field as the query parameter in the Roma-Gene enrich URL. So after we've appended the dataset ID into this URL, and we get the full the full URL we could copy into a browser here. We can then see that putting this particular link into the browser will then take us to this page, which shows all the gene sets that are enriched for our user gene set here.